At the moment t equal to 0, the force F equals AT is applied to a small body of mass small m resting on a smooth horizontal plane. A is constant. The permanent direction of this force forms an angle alpha with the horizontal figure shown given below. Find the velocity of the body at the moment of its breaking of the plane, the distance traversed by the body up to this moment. So if we begin solving this problem out, the first thing that we do is we break the component of forces. So if I break the component of force, then I can say that in this direction the force is going to act as F cos alpha, and in the upward direction it is going to be F sin alpha. A weight mg is acting in the downward direction, and at any instant of time a normal reaction force N will act. Now, first of all, when we say that the mass is losing contact with the ground, so we can say that to calculate the time when it is losing contact with the ground, the moment it loses contact with the ground, the normal reaction force is going to become 0. And if normal reaction force is becoming 0, so I can say that F sin alpha is balanced by mg in the downward direction. Now I can write that F is equal to AT sin alpha is equal to mg. So from here the time it will break off the plane can be written as mg upon A sin alpha. So this is the time when it will lose contact with the ground. So now we are writing the equation along x-axis. Now the force along x-axis is responsible for its motion on the surface while it was getting lifted off the surface. So I can write that along x-axis I can say that the force along x-axis is equal to m acceleration along x-axis. Now since we already have a term a in the equation, so we are using the term wx. Wx is representing acceleration along x-axis. So we can write it in this way, that the force along x-axis, which is equal to at cos alpha, is equal to m dv by dx, dv by dt, I'm sorry. So the acceleration is written as dv by dt. So from here I can arrange the expression in such a way that we can write it as a cos alpha t dt is equal to Vx. Now while we integrate both sides, we need to fix the proper limits. So at t equal to 0, the velocity was 0 and it break off from the surface at a time t0. So you can call this as time t0 when it break off from the surface. So at t equal to, I say that the velocity is v and it break off from the surface at time t0. So the first expression which I obtain over here is the equation in terms of time, and then we will put the value of t0 to get the velocity of the body at the moment of its breaking of the plane. So the first expression which I am writing over here is by simply integrating this term, that is we get a cos alpha, and over here there will be a mass term as well, so by m, by dividing by mass. So a cos alpha by m, and integration of t is going to give us t square by 2. So t square by 2. So this is the expression of velocity which we have in terms of time t. Now at this very instant of time, when the question is asking the velocity of the body at the time it is breaking off, so we can put this value of t and obtain the expression as a cos alpha by 2m, and t square can be written as m square g square upon a square sin square alpha. So we obtain the equation in this fashion, and on simplifying we obtain the equation of velocity as v is equal to mg square cos alpha by 2a sine square alpha. So this is the equation of velocity which we obtain, which is answer for A part. Now the question is also asking us to calculate the distance traveled. So now we are using the expression for velocity as a function of time, which we deduced as a cos alpha by 2m t square. A cos alpha by 2m t square, and all these parameter is a constant, and I can write this as v as dx by dt, which is equal to a cos alpha by 2m into t square. So we can convert this equation in the integral form as a cos alpha by 2m t square dt, and integrating both sides. Now again, if we wish to write this equation at t equal to 0, the displacement of the particle is 0, or it is at x equal to 0 mark, and at a time t it will cover a distance s. So the expression for distance in function of time can be written as t square will be written as t cube by 3. So we can write the equation as a cos alpha by t cube upon 6m. So by 3 will come in, so we will write as t cube by 6m. Now in this expression, if I put the value of t naught, so the distance before it getting lifted off can be calculated. So on substituting the value, we obtain it as m square g cube cos alpha by 6a square sine cube alpha. So we are substituting this time in this expression. The time when it is getting lifted off, we are putting this time in this expression to obtain the distance which it travels before getting lifted off.